Hello viewers, I am Dr. Mala Das Sharma. Welcome to my channel Chemphilic. Let's start 52 episode of Teaching Chemistry through Riddle. Here is our riddle number 52, which goes like this. X is a class of organic compounds possessing extra stability. Y refers to another class of organic compounds that are extremely unstable. The compounds of both the classes X and Y must satisfy three common conditions. However, they differ in their formula for calculating the number of pi electrons that should be present in them. If a molecule of class Y has a way of avoiding being its member, it can do so and gets converted to another class of compounds Z, where its stability is in between the compounds of classes X and Y. The compounds of Z do not satisfy all three common conditions of the classes X and Y simultaneously. So this is riddle number 52. Now let's see the questions. Primary question. What are referred here by X and Y? Answer: X aromatic, Y antiaromatic. Other questions are: second question. Mention the three common conditions that must be satisfied by the compounds of these classes X and Y. Third question. State the formula for calculating number of pi electrons present in the compounds of X and Y. Fourth question. Elaborate the common conditions and formula for calculating pi electrons with examples. Fifth question. Why cyclopentadiene is highly acidic? Sixth question. Why propylium ion is stable? Seventh question. How can you explain the aromatic nature of pyridine, pyrrole and imidazole? Eighth question. Which class of compounds refers to Z? Ninth question. In spite of having 8 pi electrons, why cyclooctatetraene is non-aromatic? 10th question. Why is 10-annuline non-aromatic? Now, let's discuss the answers of the question. Second question was, mention the three common conditions that must be satisfied by the compounds of the classes X and Y. And third question, state the formula for calculating number of pi electrons present in the compounds of X and Y. Let's see the answers of both second and third questions simultaneously. Now, the common conditions are cyclic, planar and conjugated. That means compounds belongs to the classes X and Y must be cyclic, planar and they should be fully conjugated. Now, after satisfying these three conditions, if the number of electrons present in the compound, electrons means pi electrons, present in the compound is in accordance with this formula, that is 4n plus 2, where n is the integer, then those compounds are aromatic. And after satisfying these three conditions, if the number of pi electrons present in the compound is in accordance with this formula, that is 4n, where n is the integer, then those compounds are antiaromatic. And if these three conditions are not satisfied, say one condition is not satisfied or two condition is not satisfied, in that case, those compounds are in the group of non-aromatic. Now, coming to fourth question. Elaborate the common conditions and formula for calculating pi electrons with examples. Now, first common condition, cyclic. What is meant by that? Cyclic means it will be a closed system. Let's see. See this benzene. It is cyclic, completely closed. Cyclic compound, completely closed. Second condition, planar. Planar means it should be two-dimensional. Molecule must be two-dimensional. That means carbon atom should be sp2 hybridized or carbon-carbon double bond is present in the molecule. See here benzene, all the carbon atoms are sp2 hybridized and this carbon-carbon double bond is present. Even here also the same thing, inside all carbon atoms are sp2 hybridized. Third condition, conjugation. What is that? See, if two double bonds separated by single bond, that is conjugation. Or double bond positive charge separated by single bond, that is conjugation. Or double bond negative charge separated by single bond, that is conjugation. Or double bond lone pair of electrons separated by single bond, that is conjugation. Now look at here, in this benzene molecule, see two double bonds separated by single bond. Here also two double bonds separated by single bond. So molecule is completely conjugated. That is conjugation of, complete conjugation of pi electrons. And same thing here also. Two double bonds separated by single bond. So it is fully conjugated. Now fourth point, number of pi electrons. Now, if the number of pi electrons present in the compounds, that means which have already satisfied three conditions, that is in accordance with this formula, or if the compounds contain 4n plus 2 pi electrons, where n is the integer, then those compounds are aromatic. If n is equal to 0, it will be 2. If n is equal to 1, it will be 6. N is equal to 2, it will be 10, like that. That means aromatic compound must contain 6, 10, 14, etc. pi electrons. Now, after satisfying the conditions, if the number of pi electrons present in the molecule is in accordance with this formula, that is 4n pi electron, where n is the integer, in that case, those compounds are anti-aromatic. That means anti-aromatic compounds contains either 4 or 8 or 12, 16, like that number of pi electrons. Now coming to benzene, how many pi electrons are there? 2, 4, 6. Each double bond means, or each pi bond means 2 electrons. Similarly, each lone pair of electron means 2 electrons. Okay. Negative charge means we consider 2 electrons. So there are 6 electrons. Already it has satisfied all three conditions, and here it is 6 electrons, which is in accordance with this formula that is known as the Hockel's rule of aromaticity. So benzene is aromatic compound. Whereas here, how many pi electrons are there? That is 1, 2, 3, 4. 4 pi electrons. It has satisfied all three conditions, but it has 4 pi electrons. So it is anti-aromatic compound. Now, fifth question. Why cyclopentadiene is highly acidic? Look at here. This is cyclopentadiene and it easily releases the proton and form this cyclopentadienyl anion. Now the question is why it is highly acidic. That means why it can easily release the proton. Now, if you compare it to this allylite proton, here pK value is 44, here pK value is 15. That means compared to this, it is highly acidic. Now, what is the reason? Here first, the pK of cyclopentadiene is 50, while allylic protons are generally at 43 to 44. Now, once again the question, why it is enormously more acidic? The reason answer is cyclopentadienyl anion is aromatic. So when it forms this anion, this is aromatic, and aromatic compounds have extra stability, and any system has the tendency to gain the stability. So this molecule, that means cyclopentadiene molecule, has a tendency to release the H plus proton and gets converted to cyclopentadienyl anion, which is aromatic and stable. So once again, how it is aromatic? See, this compound, this ion, this anion, is cyclic, no doubt, But is it planar and fully conjugated? In the cyclopentadiene molecule, this carbon atom has sp3 hybridization, which is not planar. Okay, but when it forms this anion, then hybridization changes from sp3 to sp2. Now all carbon atoms are sp2 hybridized, so it is planar. Now coming to fully conjugated, yes. See, two double bonds separated by single bond, double bond lone pair separated by single bond. So molecule is fully conjugated. So three conditions are satisfied. Now coming to number of pi electrons. Now each carbon atom, this 1, 2, 3, 4, this 4 carbon atom has 1 p orbital which is perpendicular to the plane of the molecule and containing 1 electron. So these are these 4 carbon atoms p orbital, and the p orbital of this carbon atom, it is also sp2 hybridized. Already I told this carbon atom contains a pair of electron. Now if I see this orbital picture, these p orbitals, they overlap sidewise in both the direction and form the delocalized pi electron cloud, which is the characteristics of aromatic compound. And here number of pi electrons 1, 2, 3, 4, 5, 6. That means 4 pi electrons from the double bond and 2 from the lone pair. So 6 pi electron means it is in accordance with Huckel's rule. That means it contains the pi electrons of 4n plus 2. Okay, so it is aromatic. And remember this line, whenever possible, an atom will adopt a hybridization that supports forming of an aromatic system of electrons. Any system has a tendency to gain stability. Aromatic systems are stable. So, if it is possible, it changes the hybridization in the molecule and convert it to stable aromatic compound. What has exactly done here? Now, coming to this reaction. Here, this is substitution reaction. Bromine is substituted by OH group. Now, see the question. The question is, this reaction is unusually slow. We can expect a fairly easy SN1 reaction since the loss of the leaving group bromine produces a resonance stabilized allylic carbocation. Why is it slower than the reaction of other secondary alkyl halides in SN1 reaction? It is even slower than the ones without getting a resonance stabilized carbocation. So this reaction can proceed to the formation of carbocation which is resonance stabilized. Then why this reaction is very much slow? We'll see the answer. The reason for this is the number of electrons in the conjugated p orbitals of cyclopentadienyl cation. Let's see. Now here, after this removal of this leaving group, this cation is formed, and in the cation this carbon atom is sp2 hybridized. Now all the carbon atoms are sp2 hybridized. Complete conjugation is present. Two double bonds separated by single bond, double bond positive charge separated by single bond. So complete conjugation, that means it is resonance stabilized, but still it is unstable. Why? We have to calculate number of pi electrons. Here, how many pi electrons are there? See, for this 1, 2, 3, 4 carbon atoms, the p orbital which is perpendicular to the plane contains 1 p electrons. And this carbon atom's p orbital is vacant. Okay, that is also perpendicular. They can overlap and form the delocalized pi electron cloud, no doubt. But number of pi electrons will be 1, 2, 3, 4. That means these 4 double bonds, 4 pi electrons. 4 pi electrons means it is in accordance with the formula of 4n pi electrons, that is anti-aromatic compound. So, this cation is anti-aromatic and unstable. No system wants to proceed towards instability. So, this molecule does not have a tendency to form this unstable cation. That's why this reaction becomes very slow. Now, sixth question. Why tropylium ion is stable? Now, tropylium ion means cycloheptatrienyl cation. Why it is stable? It is aromatic. Let's see. Now, this is tropylium cation, 7 carbon atoms, and in the cation, this carbon atom also sp2 hybridized. So, all 7 are sp2 hybridized. That means the molecule is planar, or it is cyclic, and fully conjugated. 2 double bonds separated by single bond, double bond positive charge separated by single bonds. Okay. Now, we have to calculate the number of pi electrons. Here, from all 6 carbon atoms which are forming this double bond, these 6 carbon atoms, each carbon atom has this perpendicular p orbital containing 1 electron, and this carbon atom where the cation is formed, this p orbital is vacant, and so therefore number of pi electron is how many? 1, 2, 3, 4, 5, 6. It is coming from 3 double bond. Here it is vacant. As this number of pi electron is in accordance with Huckel's rule of aromaticity, that means 4n plus 2 pi electrons. So this cation is aromatic, hence it is stable. Now, 7th question. How can you explain the aromatic nature of pyridine, pyrrole and imidazole? See here. Pyridine, this is heterocyclic compound. In the ring, one heteroatom, that is nitrogen, is present. Now, all the carbon atoms are sp2 hybridized. Even this nitrogen also, unlike this other amines, it is also sp2 hybridized. Okay. And nitrogen with the sp2 hybrid orbital, it forms this 2 sigma bond with this 2 carbon atom, and another sp2 hybrid orbital contains this lone pair of electron. So nitrogen also has a electron in the p orbital which is perpendicular to this plane. So all this carbon atom and nitrogen atom has p orbital. See, 1, 2, 3, 4, 5, 6, these p orbitals, 5 from these carbon atoms, 1 from the nitrogen atom, which are perpendicular to the plane, and each p orbital contains 1 electron. They form the conjugation or delocalized pi electron cloud. And this lone pair is present in the sp2 hybrid orbital of carbon, which is out of this conjugation. So it is cyclic, conjugated, and number of pi electrons are 6. That means in accordance with Huckel's rule, 4n plus 2 pi electrons. So pyridine is aromatic. Now coming to pyrrole. In pyrrole, there are 1, 2, 3, 4 carbon atoms, and in the ring there is 1 nitrogen atom. Here little difference is there. In this case also, like all the carbon atoms, nitrogen also sp2 hybridized. But here, with the sp2 hybrid orbitals, nitrogen forms 1 sigma bond with this carbon, 1 sigma bond with this carbon, and another sigma bond with hydrogen, and this lone pair of electron is present on the p orbital which is perpendicular to this plane. So, if we see this condition, it is cyclic, and here conjugation is there. 2 double bonds separated by single bond, double bond lone pair separated by single bond. So it is completely conjugated. Now, number of pi electrons, if you see the orbital picture, each carbon atom has p orbital with 1 electron. That means 1, 2, 3 carbon atoms means, 1, 2, 3, 4 carbon atoms means the 4 p orbitals and 4 pi electrons, and this nitrogen p orbital contains 2 pi electrons. That means 4 pi electrons comes from the double bonds and 2 pi electrons from the lone pair. So total 6 pi electrons. It is in accordance with Huckel's rule. So it is aromatic, fully conjugated, and nitrogen changes the hybridization to sp2. That means in this molecule hybridization is sp2. Now coming to imidazole. See this molecule. In the imidazole, there are 2 heteroatom, 2 nitrogen atom in the ring. Now this carbon atom 1, 2, 3, these carbon atoms are sp2 hybridized. Even these 2 nitrogen atoms are also sp2 hybridized. So molecule is cyclic. And here what happens, if you see this orbital picture, here what happens, this nitrogen atom, here it forms with the 3 sp2 hybrid orbital, it forms 2 sigma bond with 2 carbon atoms and 1 sigma bond with the hydrogen. And this lone pair is present on the p orbital which is perpendicular to this plane of the molecule, this one. Okay. But for this nitrogen atom, here also 3 sp2 hybrid orbital is there. 2 sp2 hybrid orbital involved in the formation of sigma bonds with 2 ring carbon atoms, and another sp2 hybrid orbital contains this lone pair of electrons. So that is not taking part in the pi bond formation. So this lone pair of electron is in the sp2 hybrid orbitals in the plane. So it is not taking part in the conjugation or delocalized pi electron cloud formation. Okay, so this molecule is cyclic, completely conjugated. So how many number of pi electrons? This 1, 2, 3, 4. That means 1, 2, 3, 4 means 1 carbon atom, 2 carbon atom, 3 carbon atom, and 4th one from nitrogen. And from this nitrogen 2, that means from the lone pair 2, that means 4 plus 2, 6. 6 pi electrons means it is in accordance with Huckel's rule of aromaticity. So what I explained, that is only written here. Now, 8th question. Which class of compounds refers to Z? Answer is non-aromatic compounds. Now look at here. If any of the factors, either cyclic or planar or fully conjugated, if any one is missing, then it is, or any two is missing, then it is non-aromatic. Say for example this one, this is not cyclic. This is cyclic but it is not planar. Carbon atoms are sp3 hybridized. And you know these alicyclic compounds, they are not completely planar. It's same thing here, though here one double bond is there but not fully conjugated, and it is not planar, and this is not cyclic. And similarly here also same thing, cyclic but not fully conjugated and not completely planar. This is not cyclic. Here also cyclic and here conjugated but not planar. There is no space for this 2 hydrogen. This is 10 aniline. Now, 9th question. In spite of having 8 pi electrons, why cyclooctatetraene is non-aromatic? Cyclooctatetraene. Okay. Then here it is cyclic, no doubt, and everywhere 2 double bonds separated by single bond, so it is fully conjugated, and it has 8 pi electrons. See, each double bond means 2 pi electrons, so 8 pi electrons, which is in accordance with 4n pi electrons, that is anti-aromatic compounds. Now, again you have to remember, every molecule tries to gain the stability. If the molecule has a way of avoiding being anti-aromatic, that means avoiding being unstable, it will do it. How it has done it? Look at here. Change the structure like this. Here, p orbitals of adjacent double bonds cannot overlap. It is like separate alkenes. Okay. So, it becomes, if this structure means it is anti-aromatic, but it has changed the structure like this and it becomes non-aromatic. Stability of the non-aromatic compounds are in between aromatic and anti-aromatic. They are less stable than aromatic but more stable than anti-aromatic. And here in this molecule, it easily undergoes this electrophilic addition reaction, even see at low temperature minus 50 degrees centigrade, and give the addition product. Why? Because if in the addition product, it can get rid of this strain which is present in this structure. So, cyclooctatetraene undergoes regular electrophilic addition reaction that alkenes do at even lower temperature to get rid of the strain associated with this geometry. Now, 10th question. Why is 10-aniline non-aromatic? Now, 10-aniline has 10 pi electrons, which is in accordance with Huckel's rule, 4n plus 2 pi electrons. But still it is non-aromatic. Just now I told, because here it is cyclic, fully conjugated, but it cannot be completely planar. There is a lack of space for these 2 hydrogen. They cannot remain in the same plane. So, it is non-aromatic because it cannot adopt the planar geometry because of this 2 hydrogen, for which no space. Now, naphthalene also has 10 electrons. It is aromatic because here the carbons are joined. And when it is in naphthalene 10 electrons, then this molecule is planar. So it is aromatic. But in 10 aniline, these two carbon atoms, they are not joined. Hydrogen atoms are attached. If these hydrogen atoms are removed, then it becomes naphthalene and aromatic. But if the hydrogen atoms are there, there will be space problem. So it is not planar. So if the carbons were connected, thus removing these hydrogens, we would have naphthalene, which is now planar and aromatic. So this is all about our discussion on aromatic, antiaromatic and non-aromatic compounds. Thank you.